Hello everyone, this is Mateo with arcade.dev, and in this explainer I wanted to talk about ReAct agents and sort of loosely expand into the possibilities and the overarching pattern that ReAct agents and generally also like planning and execution agents follow, right? This is the idea of combining a reasoning step with an action step. And we will see that this is taking many shapes and many names, but fundamentally they will follow the same sort of pattern. So let me go ahead and explain how that works. Arcade is the best platform for agentic action. It unifies all your models, agents, tools, and MCP servers into a single platform that handles tool management and authentication seamlessly. Arcade is built by experts in AI, identity, and distributed systems. Try Arcade today at arcade.dev. So the ReAct name in this case comes from Google Brain in 2022 from this article called ReAct, Synergizing Reasoning and Acting in Language Models. We will see that this is not a new thing necessarily. It was innovative at this time because of the patterns in which LLMs were being portrayed. So we had reason, like chain of thought, and action, which is observe and act, and then ReAct is reason and action. I want to decompose this a little bit into what I think is the kind of governing pattern of this type of agents. This won't be super academically accurate, so if you're thinking, no, ReAct is not the same as execution and planning, roast me in the comments. The idea here is not to be so strict around what ReAct specifically or this specific implementation is, but rather how to think about LLMs as agents and how to get them to actually be useful and how this takes the shape of ReAct most of the time. So let me go ahead and make a diagram. ReAct patterns. The logic here is essentially we have an LLM and this is going to be the brain of the agent, and then I'm going to make an arrow coming from nowhere. This is going to be the prompt, right? So the prompt is the thing that comes from the user / environment, and it's going to tell the LLM this is what we want to do. On its own, the LLM can just generate some text and maybe give a response. But the idea of ReAct is we can use the LLM as a source of reasoning, as a source of thoughts. What happens in this case is we think about what to do in the LLM box, thinking, and then here we have action. And we can iterate in this as a loop. So we go here. The agent decides I need to take action. It gets the response from the tools. Actions actually are implemented as tool calling, which is what Arcade provides, for example, for your agent. There will be another arrow here. This is the output of the agent. So this is the kind of the general pattern, right? And we just recreated the ReAct implementation. Right? In the real world, however, action is more complex than simply this. Right? There are many things that need to happen for action to meaningfully happen. Because here we have the tool invocation, and then in this diagram it's just like, okay, the action happens. But it's more than that, and this is going to be like the result. But it's actually more complex than this, and I want to expand this box first, and then we'll expand the thinking box as well. Because they are more related than what you actually think, and there is a spectrum of different architectures, if you wish, that follow this pattern but divide the responsibility of the thinking more or less into this action box. So, okay, I will decompose this a little bit. What happens internally is we have the tool, and the tool can, for example, require auth question here. So you get the invocation has to come here to the tool, and this is execute. You get the parameters from the LLM, execute this tool, and the tool will go into my app, specifically into this question, which is, does the user or does the LLM have permissions to run this tool? So there's going to be another box here. I'm going to say run. Then we reply with the results, and this is going to be passed back to the LLM maybe. So this is going to be yes, arrow, but there may be a no arrow. The no can be handled here, present off. So this is going to be the no. And then present off is, okay, if the user executes, if there is a yes, or actually, it's going to be another question, which is going to be, do we have permission? No. Then we present the off, and then the off is going to be another question, specific question to the user, where the user now has another color, maybe it's orange. The user needs to take action here. Is going to be present off. They can say no or yes, and if they say yes, we go back to the run. This is going to be happy path, yes. And if no, return negative result. So in this path, we already have one of the loops here where we invoke the tool, we get the runtime to execute the tool, and the tool runtime here will say, okay, does the LLM have permissions to run this tool? If no, and also if the user says no, it's going to be a negative result. Actually, let me color this red, and this is going to be green, so that it's easy to see what's going on, like that. This is going to be green path, and this is our unhappy path. So no, everybody is sad, and we say you cannot run this tool, and that goes back to the LLM. But there are other things that can happen here. Does the LLM have permissions to run this tool? Yes. But there could be another question here, actually, right? So here we move this a little bit more, and let me make this, and it's gonna be policy check. And the policy check can be yes or no, and the policy could be something like, okay, is this user in the allowed list or not? If yes, we just run. So let me make the happy path easy to see here. Policy was successful. We can send the email, we can buy the product, all of that. If no, we have another option, and the option is to bother the human again, right? So this is going to be human in the loop. Why are we in this situation? This happens when the LLM can run the tool effectively. This is going to be the no arrow, right? And this is going to be human in the loop, right? And this is optional, right? Optional. In some cases, we just don't want to bother the human, and it's going to be just silently fail. Human in the loop, maybe. And the human can say, no, I don't want you to send that email. No, I don't want you to buy that thing or whatever. Or it can say yes, right? So actually, let me put this on that other side. Let me bring the arrow over here so that all of the happy paths are close to each other. Here we are. It's going to be the yes path. It's great. Human in the loop, the human says, yes, go ahead. So now we have everything that we need, right? So LLM has permission to run this tool, yes. The policy check says, hang on, this is not in the allow list. So, go ask the human, go get the permission, whatever. And we here can decide, to present this to the human, and the human says, yes, run it. Or if it says no, we go ahead and we give a negative result. This is going to be red. So this is going to be more often than not an actual implementation of an agent. And this is how ReAct truly looks like, right? So the action itself has all of these interrupts, right? So all of these are a specific statically programmed flow that the agent needs to consider, right? The program is enforcing this, not the LLM, not the agent itself, is the runtime, right? This is the tool runtime that requires this. Get the execution, we have the tool, we have all of the stuff. Let's make sure that we are actually allowed, right? So all of this is very important because the thinking is something, okay, it's gonna rely on this result. Yes, we send the email. Yes, here you have the, Wikipedia article, all of that. And a lot of things can happen here. And the result could be also an error. Like we can actually get all of these checks. We run the tool and then we get an error from the API and we have to retry again. And we are in this loop. I just wanted to expand this into how it actually looks like because it's more complex than just take action. And another thing here is that, I put thinking here in this box. But one of the patterns is also having a think tool. So you pass some context to a tool and the tool will internally, for example, think its way into the task, right? So task or the prompt comes in, the LLM says, I don't know how to do this. And we have a tool that says think, and then it's gonna go make a plan or whatever, and then come back with a plan, right? So that's why I think like React patterns are very, very, very similar to a different pattern that is also called plan and execute. Technically, they are not the same. Plan and execute is normally divided in the same way, like you have a plan step that will plan out all of the different steps and then execute multiple steps. And React, the idea is to have a tighter loop around thinking and action. So you think, then you act, then you think, then you act, then you return the output. But the thing is that action could be thinking itself. So this is compatible with plan and execute. So I want to just kind of put the thinking and action, or like the thinking action, the reasoning and action, the planning and execution, all of that into a spectrum, right? We are seeing all of these strategies about, okay, we need to think one step ahead and then act, or multiple steps ahead and then act. So I will talk about this in depth in another video about the actual planning, but I want to give you a sense of how powerful this is, because here we are interacting with the environment. So the prompt is going to be the sensing, maybe the actuator happens here in the action, but then the thinking could also involve a tool, some action, right? And this is true also for the way we operate in the world, because it can be something like, okay, I as a human decide to reason my way into a specific task, but I'm going to go take action, consult a book, consult Google or whatever, and get the information I need, get the context I need to actually fulfill the task. My goal in this video was to sort of graduate the React idea as a more overarching architecture for building agents. It's not exactly the React, the paper version of React. It's also not exactly plan and execute, but these patterns are very closely related to one another. And I wanted to highlight that, expand on the action bit, which I think is what truly gives agency to agents. And then in another video, we will explore the planning and how to approach planning in multiple different strategies. Until the next time, happy building.